Welcome to this video on kinematics in one dimension. In this short lesson, we will focus on how to describe motion along a straight line. By the end, you should be able to identify an object's position, calculate displacement, and explain why distance and displacement are not the same thing. Kinematics is the language we use to describe motion. At this point, we are not asking why the object moves. We are only describing how it moves. Later, when we include forces, that becomes dynamics. Together, kinematics and dynamics form mechanics. In this part of the video, we start with kinematics because we first need a clear way to describe motion before we can explain what causes it. Before we can talk about position or displacement, we must choose a coordinate system. For one-dimensional motion, the coordinate system is just a straight line. We choose an origin, choose a positive direction, and then assign a position along that line. Most of the time, motion to the right or upward is positive, and motion to the left or downward is negative. The important point is that the sign of a quantity depends on the coordinate system we choose. Once the coordinate system is chosen, the position of an object tells us where the object is on that line. We usually call the initial position x naught, and that means the position of the object at the initial time, t naught. And then for the final position, we call it xf, and that is the position of the object at final time. And the displacement is given by final position minus initial position. And we indicate displacement using delta x. So delta x means change in position. Displacement is a vector quantity. That means it has both magnitude and a direction. So the sign matters. A positive displacement means the final position is in the positive direction from the starting point. A negative displacement means the final position is in the negative direction from the starting point. Let's look at an example. In this example, we have a teacher moving from one position to another in front of a classroom. So the initial position of the teacher is at 1.5 meters according to this coordinate system defined here. And teacher moved to the right 2 meters. So here this is the new final position. Now initial position is 1.5 meters, final position is 3.5 meters. So the change in position delta x is x final minus x initial, which is 3.5 meters minus 1.5 meters, and that gives us positive 2 meters. So the displacement is positive 2 meters. As I mentioned before, displacement is a vector, so we can use an arrow to indicate displacement. So this arrow right here indicate the displacement of this teacher, that is from this initial position x naught to final position x final. Let's look at another example. In this example, a person sitting in this seat right here moves from that position to the back of an airplane. So the initial position of the person is at 6 meters according to this coordinate system, final position is at 2 meters. So the change in position is now x final minus x initial. So x final is 2 meters, x initial is 6 meters. So we get the answer as negative 4 meters. Now the displacement is negative 4 meters. Now if you look at this picture here, this displacement vector arrow is now pointing to the left. So the left hand side is the negative direction and the right hand side is the positive direction. So here the displacement is a negative value. Distance tells us how much ground was covered. It is always positive. Displacement tells us the change in position from start to finish. In this example, the player moves across the court and returns to the starting point. The distance is not 0 because the player did move, but the displacement is 0 because the initial position and the final position is the same. So delta x, x final minus x initial will give you 0. So remember, distance depends on the path, but displacement depends only on the start and end positions.